All right, I'm going to get started here. So before I start the actual presentation, I'm just going to show the students in the room how to get to the research guide that I made. And if you're on the Evans Library homepage, you can just click Research Guides. And then it would be under by course or topic. And from there, go down to Topic Guides, and it's just labeled Open Data. There it is. And I wanted to show everyone this because it's a permanent resource, so in case you don't remember something that I say, you can come here and look at it. But it also has a lot more information than what I'm going to cover today. There are also the slides from my presentation today right here that you can download later. And another way, which is maybe a little easier than navigating through all of that, is just to go to Google and type in something like Open Data LibGuide at Florida Tech, and it'll be one of these that says Research Guides next to it. That's just another way. It won't take you to the home page right away, but that's just an easier way to get to it.
So you said go to Google and then type the Open Data?
Try typing in Florida Tech Open Data.
Okay. Then we can go to what tab? So it's a common data set?
No, that's not it. It will say Research Guide next to it, so I'll show you again how I did it. So yeah, I just typed in Open Data LibGuide Florida Tech, and then it's going to be one of these with Research Guides next to it. It won't take you to the home page, but it's a really easy way to get there.
Okay, so it's the Open Data Source Research Guides?
Yep.
Okay.
Yes, that's
Yep.
the most.
All right, so without further ado, I'm going to start my presentation. Oh, it's recording. Right, that is recording. Okay, so to introduce myself, my name is Mike Dickinson. I'm the new data librarian here at Florida Tech, and this spring I will also be the library liaison to the Department of Aerospace, Physics, and Space Sciences. So we have a couple goals for today's workshop. We only have a half hour, and I'm going to cover a lot of things, so hopefully we can just become familiar with open data policies and concepts and gain a little experience searching for open data sources. It's a pretty simple concept when it comes down to it, so this should go pretty quickly. Before I start talking about open data, I'm going to talk a little bit about where we're at in terms of the current landscape of data collection around the world. And this might be a little bit of review, but it's important to ground us somewhere. So the amount of data that is being collected is constantly increasing, and huge amounts of data are being collected every day. I think it's like every second there are 40,000 Google searches, and 4 million people are watching a YouTube video at any given time. Everything that we do can generate data digitally, and scientists and researchers are always finding better ways to measure any kind of phenomenon they want to observe, and that's where data really comes in. The impact of this is that there is an increased demand for data-savvy researchers to the point where people are starting to accept the idea that all scientists are, to an extent, data scientists. So being able to work with and understand the concepts of data is more important than ever, because all of this data has a huge amount of potential for us to generate new information. And before I move on to our main topic of open data, I'm going to talk a little bit about data sharing, because open data is an aspect of data sharing, so it really rolls into it. And data sharing is just what it sounds like. It's making your data available to others to use and interpret. And that benefits the general public because information is useful And when people have access to information and to data, it becomes more useful, and they might use it in more interesting ways than the original researchers. That goes for the scientific research community at large. If a researcher makes their data available, other researchers might try to find another use for it or run a different kind of model on the data and learn something different than the original researcher learned. The researchers themselves benefit from data sharing because they typically will, if they don't get credit for what other people do, at least their name is getting out there and other people are reading their name and understanding the kind of work that they're affiliated with. And funders also have requirements to share data, so especially government agencies. We'll talk about that a little more later, but they also benefit because they're not essentially breaking federal mandates. And some people don't share data. It's something that is still too common, although that is changing. The open data movement is moving forward and more people are making their data available. One of these reasons, one of the main reasons, would be a confidentiality constraint. Any kind of data set that involves personal information of human subjects is probably not going to be easily shared. And you could potentially scrub the data and take that personal information out, but then it would change the meaning of the data, and that's not necessarily a good thing. Fear of misuse or misinterpretation is a valid reason not to share data. If someone's going to do something bad with it, then you don't want to share it. And there have been examples of this. We'll see one later, but so far there haven't been really major terrible things yet. Just a couple instances. Researchers do want that acknowledgement, and they might not get it if they share their data. Publication embargoes are another thing. When someone publishes data that's associated with a paper in an academic journal, the journal might put an embargo on that data, and depending on the journal, that might be 1 year, that might be several years. It just varies from publication to publication, and that is really a big issue still. But they're trying to make money. They're for-profit businesses, so they'll do what they want to do. And then to maintain a competitive edge is another big reason, especially in commercial industries. Apple isn't going to share their information or their algorithms for Siri, for creating Siri, because Siri is a lot better than some of the other voice-activated assistants out there. So if you want to maintain a competitive edge, you're not going to share your data. And now we're going to move on to our actual subject, which is open data. And open data is a really simple concept when it comes down to it. You have the standard definition up there that it can be freely used, modified, and shared for any purpose, but all you really need to know is that open data can be accessed and used by anyone without restriction. You can do it for any reason. You can use it, you can modify it, you can copy it, you can share it with other people. There's no restriction. The only caveat to that is that you might have to give credit to the original owner or the group that generated the data. But it could still be open even if you have to attribute the original creator. And this movement, the open data movement, is a global movement. You might call it a social movement because it's happening everywhere and it is moving forward, but there are some policies, government policies, that have a significant impact on this. And this is really just a summary. There's a lot more in the research guide that can break this down in depth. But what you really need to know is that the policies of open data really started with the Obama administration a few years ago, about 10 years ago, and President Obama issued a few executive orders, the most important of which mandated that any government agency that receives over $100 million in federal funding for research has to make that data available to the public. And they have to do so in a timely manner. And that affects huge agencies like the Department of Defense, the Department of Health and Homeland Security, pretty much everything you can think of. And so all of that data is made available to the public and then aggregated in data.gov. There was the Data Act in 2014 that requires federal agencies to publish their spending data each year, or each quarter, and that is also relevant to something we're going to talk about a little later on. But what we really need to know is how things stand currently, because the Obama administration isn't in office anymore. Now we have the Trump administration, and I'm happy to say that their policy as a part of the president's management budget is to leverage data as a strategic asset, which is essentially the same thing as what the Obama administration was doing. So he hasn't really changed anything yet, but he could if he wants to, and that's something to pay attention to. Personally, I don't think the policy on open data is going to change anytime soon. It's also worth noting that there is other legislation in the works right now that will refine the Data Act and the Obama memos, but they're still awaiting a vote. You can read more about those in the research guide. Now I'm going to talk about a few case studies. This is also meant as a visual guide, so there's a lot of text on the next few slides, but it's really pretty simple. This one comes from the United Kingdom government with this guy named Liam Maxwell, who's the Chief Technology Officer over there. He wanted to see if different departments across the government were spending money for duplicate versions of these same really expensive market research reports, and was able to use a website created by others called openspending.org, where they aggregate spending data from different nations all in one place, and he was able to search across all the different departments at once because there was no other way to do this. These people did it using the open data, and found in a few minutes that different departments were buying these market research reports and saved £4 million, which is over $5 million US dollars in a few minutes. Anytime the government saves money is good for the taxpayers. So that's one really good example where just a little bit of effort using open data can make a big difference. I've got another more complicated case study for the positive benefits, and this comes from the court case, Kennedy versus the city of Zanesville, Ohio, which occurred in 2008. Here we see Zanesville on the map, and Coal Run was a neighborhood of Zanesville. It is currently a neighborhood of Zanesville that did not have access to public water lines. In 2008, that's a pretty big deal in the United States. It also happened to be that this neighborhood was populated by predominantly African-American residents. So water lines take a long time to develop, and this policy of discrimination went back at least 50 years to an era of segregation where this sort of institutionalized and systematic racism was more socially acceptable, although you can definitely say that the water companies since the end of segregation dropped the ball in not outfitting the neighborhood with the proper amenities that is the right of any citizen in the country. So the residents were able to use a map they generated using open data that came from the water company to prove a correlation between person skin color in the neighborhood and access to public water. As a result, this map revealed the discrimination, and the plaintiffs were awarded over $10 million. So that was about 10 years ago. There are a ton of really good examples of why open data is useful and how it can positively benefit people. There are a couple TED Talks in the research guide that have really awesome examples. I just didn't want to take one right out of there because they're worth watching. But here is another example, and this is one of the potential negative consequences of open data. And this also happened in 2008. So 10 years ago, the 8 Maps case occurred, and a little bit of background on what happened here was that in 2008, California voters passed an act called Proposition 8, which made same-sex marriage illegal in the state. That's kind of hard to imagine now that it has been federally legalized by the US Supreme Court. But yeah, 10 years ago they made it illegal, and so the opposition released 8maps.com, which was built using open campaign finance data, which is legally required to be made available to the public. And it's an anonymous source that created this because this was super illegal, but they used this open campaign data on a Google map to reveal the names, the amount donated, the approximate location, and even in some cases the employers of the people who donated to the Proposition 8 movement, so that same-sex marriages would be illegal in the state. So here we have a map of the Los Angeles area that shows the approximate locations of people who donated to this act, and even though in the year 2018 we might consider making same-sex marriage illegal kind of socially repulsive, it's still not right to be putting people's personal information on the internet like that. And now I'm going to move on to open licenses, and you can see a lot about this in the LibGuide, but I'm just going to cover a little bit on each license right now. There are two main types of open data licenses you can attach to your data to make it open for the public to use. The first set are the Creative Commons licenses, and there are more Creative Commons licenses than this, but some of them have restrictions that wouldn't make your data completely open. So I haven't included those there. These are the ones that will make your data open. The first one is the zero license, which just makes it open. No one has to give you credit if you're the original owner to use it, to modify it, to share it, to copy it, anything they want to do. There's the attribution license, which requires that they give you credit. They can still modify it, change it, use it, access it whenever they want, but they have to say that you were the original creator. And then there is the attribution share-alike, which means if they modify it and change it in any way, not only do they have to give you credit, but they also have to put the new product, whatever they've created, under the same license, so that anybody who takes their work and changes it also has to put it under the license. So it's a never-ending chain of making open products available. Then we have the Open Data Commons licenses, which are also good licenses and are quite similar to Creative Commons. The public domain dedication and licenses make something in the public domain. You don't have to attribute it to anybody. There is the attribution license, which is pretty much just like the Creative Commons license, but also an open database license, which allows people not to modify data, but to modify and change databases themselves. And it is pretty easy. If you go into the research guide and click on one of the links, it will give you an example of how to add the license. It's really easy. It's as simple as just, you can even copy and paste. It will say, this is protected by a Creative Commons zero license. You just copy and paste it and put it either in the repository you're depositing your data in, or even on a README file that you include with your data. But it's a really simple process to make data open, and then it's legal for anyone to do whatever they want with it. And here we have just a few open sources. The research guide has a lot more. These are just some of the most important ones. Data.gov has all of the federal government data, and it's probably your go-to source in most cases. And then we have United Nations data, which also has aggregated country data. And the NASA data portal is also useful for, or at least relevant for our students here. Here are a few of my favorite learning resources. Again, there are a lot more than this on the LibGuide, but there's a link to the LibGuide, but there's the Open Data Barometer, which compares countries on how they're doing in publishing open data and government data, which is really interesting. The US Open Data Toolkit is also really interesting. It has best practices for sharing open data. And there's a lot more on the LibGuide. These are just some of my favorites. And one final thing I'm going to talk to you about before we get to our activity is data quality. And data quality is tricky because bad data can derail an entire experiment. And unfortunately, there's no end-all resource that can tell us that data is of poor quality. Generally speaking, you can trust government resources, but there's just no way to be certain. You have to go about it yourself and make the choice yourself. So a few things you can take into consideration are the researchers who are collecting the data. If it's someone who has a really good reputation and has produced good research, and impactful research, you can probably trust that they know what they're doing. If they have a PhD, they probably know what they're doing. If it comes from a no-name source somewhere in the Netherlands and you've never heard of this, you might not want to trust that data. The funding body is also important. You can trust the National Science Foundation is going to fund projects led by well-qualified researchers, whereas data funded by a commercial enterprise might have some kind of bias to it. You also want to consider the time the data was collected, because while data that was collected 50 years ago might be useful to the experiment or project you're working on right now, it might also have really no impact and could really mess up your experiment if it's not relevant. There are a few other things you can look for. The repository, if it's a trusted repository, which I could say a lot on, but a trusted repository is essentially one that has really good credentials for storing data. If the data is being stored somewhere really random, sometimes people put data on GitHub even though it's not really meant for GitHub. I personally wouldn't trust most data that's put on GitHub, depending on where it comes from. If it's just a random user, you might not want to use that data, but if it's put on GitHub by NASA, that might work for you. It just really depends. You also want to consider the original purpose, because what one person uses data for, it might be applicable in other situations, but it might not as well. So it's really good to consider how it was originally collected and why. And also how well it represents what is being measured. A lot of null values, a lot of inconsistency with the data, a lot of typos could be a red flag to maybe stay away from it. But in the end, it is ultimately your decision as the researcher. We can try to help you decide if a data source is credible here, but it's your decision in the end. And now we've got a little bit of time for an activity, and I've passed out the handout. So all we're going to do is just pick one of these scenarios. Hopefully it is relevant to what you do, and try to find some data sources that would work for these.
Do we have more?
Yeah. And you can use the LibGuide. There's a tab on the LibGuide that says data sources.
Did everybody get to the LibGuide?